Okay, so we need to open the implementation file for the string, which is string cpp. So we're just going to open this file and copy and paste perhaps this section somewhere in this file. So we already have example of overloaded operators right here, but this is a non-member overloaded operator. This time we have an operator defined, assignment operator defined as a member of the class string. So let's add the signature. So I'm just going to get rid of this, and this is the declaration. So we of course need to remove the semicolon to convert this to a definition of this function operator, and this time it becomes a member of class string. So now it has to be prefixed with the name of the class. So of course colon is a scope resolution operator. Okay, so so this should help us with this situation where we can change the hello string or any other string and reassign it back to the original string. And even though there is a temporary object created in the middle of this assignment, when we make a copy of it using this operator, we will be making a deep copy of that temporary object, and therefore it'll be safe to get rid of it. So let's take a look at its implementation here. So first of all, you typically want to say that here, I'll just copy and paste here and give you an example, that when you have an assignment, normally you would like to prevent the implementation of your assignment from self-assignment. Essentially, if somebody says hello string equals hello, it should be ignored, right? You don't want to do anything. You just say, okay, that's nothing I worry about. I really don't have to change anything. So this is called self-assignment, which may happen directly or indirectly, doesn't matter. We want to prevent this from happening. So how can we do this? We're passed the reference to another object through the reference named another. And now we can compare the address of our current string with an address of that another string. So basically concatenate here returns a temporary string. So we're going to be getting address of that temporary string. And we'll be checking whether it's the same object. And if it's the same object, we just say, okay, let's return the reference. Assignment operator requires that you return a reference to this object, which allows to implement chain assignments in C++. Okay, so that's just a signature. How do you initialize this reference? You just return, you can take this, which is pointer to our object in memory, basically this object in memory, and dereference it to convert pointer to an object, and the object becomes good enough to initialize reference that we're supposed to return from this operator. So this is one thing, one of a concern for us. Now let's bring it back to previous document group, and once again what we really have to worry about is this part where we have the potentially pointer part of our string implementation. If you review previous videos that we've covered development of this class, right? So this could be a null pointer, then we don't have to worry about it much. But if it's not a null pointer, that means that this object here owns dynamic memory. Okay, so let's just do this next part. So this another check is that if our pointer to string is not null pointer, our object owns dynamic, right, dynamic memory. So we need to free up that memory, right? So we're kind of doing the same work as our destructor is doing in case when the object is going out of memory. So under any circumstances where we have an object is just to be assigned something, and we realize that we already own dynamic memory, so it's not null pointer. So this here points to some dynamically allocated memory. We say let's delete that memory right away. So we want to deallocate dynamically allocated memory. So that needs to be addressed. Okay. Then we can also examine another object and say that for example, right here, next, very similar concern is that we say that then if another object, another string, also owns some sort of memory allocated dynamically, and remember that the rules are is if this is not a null pointer, object owns dynamically allocated memory. So we need to make a deep copy of that. So what we do, we examine the length of another string, we add 1 once again to provide space for 0 terminating character because this is a C-like string, and we use C library string copy to just copy from another string into our brand new dynamic memory because the new operator allocates dynamic memory. So at this stage, if another string that we got as a parameter to our assignment, if it owns dynamic memory, then we will make sure that we copy this another string information into dynamically allocated memory by this object. And then with the string view, what we do, we just point our string view to that brand new allocated memory. And this is how we can take care of a deep copy of another string. Now, otherwise, okay, so if another object does not own any dynamic memory, then what we can do is just we can then assign a string view and pister like this, right? So in that case, I'll just show you like this. So if another object does not own any dynamic memory, we just say, okay, we'll continue using the current string view that it has. So we just copy string view over here, but because there could potentially be a change over here, so we just make sure that our pstr pointer to dynamically allocated string is null pointer, which means that it does not own any dynamic memory. So these are all cases that I can envision over here, and it's a requirement that assignment operator that we overloading has to return a reference to the object itself. So this is normally done by taking the this pointer and dereferencing it. Okay, so remember we had this issue right here. We had before this was in place because the memory was not managed properly. This was causing us problems. We tried to deallocate memory twice, which is really bad news for free store and dynamic memory manager that C++ is using. So I'm going to save everything and I'm going to build this. And let's run it for the sake of testing. Okay, so I'd like to remove these destructor tracing messages, by the way, because we no longer need them. It was done there just for debugging purposes. I'm looking for my destructor in this code. Okay, so this is the destructor and this is just for debugging. Okay, so this was done for debugging reasons, so I'm going to clear this up. And of course we can again print our string after concatenating it with some spaces. Okay, so let's see how can we get this? Just probably use square brackets to indicate the beginning of the string and the ending of the string, like this, and it should be good to be able to view this. So now this is a much better version. So here we just regenerated hello string, and now it includes some spaces at the end over there. Okay, so my next question is, how could we then add spaces in front of this string? Okay, so let's find out.